Uh, Hi, my name is Mohamad Khairie bin Mohamad Aizie. I'm from RK23, which is Electrical System Engineering. I'm from G1, and today I would like to present to Dr. Tiang about the EET 208 Electrical Power Technology analysis of three-phase transformers in Y connected generator. As you can see, this is I do the slide for you to more understand lah. Okay, this is for my introduction. But before that, I hope Dr. Tiang be safe and stay at home. Uh, Enjoy your holiday. Okay, for the introduction, I will read for you. A transformer is a device that changes as electric power at one frequency and voltage level to AC electric power at the same frequency and voltage level to AC power at the same frequency and another voltage level through the action of magnetic field. One of the transformer winding is connected to a source of AC electric power and the second transformer winding supplies electric power to loads. The transformer's winding connected to the power source is called the primary winding or input winding. And the winding connected to the load is called secondary winding or output winding. A transformer ideally change one AC voltages to another voltage level without affecting the actual supply. If a transformer steps up the voltage level of a circuit AC, it must decrease the current to keep the power into the power into the device equal to the power out of it. Therefore, AC electric power can be generated at one's central location. Its voltage step up for transmission for over long distances at very low very low loss, and its voltage step down again for final use. Transformers for three phase can be constructed in two ways. First is three single phase transformer can connect them in three phase bank. Second, three phase transformer can consisting of three set of windings wrapped on a common core. This design, which are three separate transformer and a single three-phase transformer being used nowadays, both also have their own advantages. For single three-phase transformer, it is lighter, smaller, and cheaper, and slightly more efficiency. But by using three separate single phase transformer has a benefit that each unit in the bank could be replaced individually in the event of trouble, and utility would only need to stop a single phase spare single phase transformer to back up all three phases. Okay, this is only for the introduction. Okay, this is objective for my uh, assignment. My first objective is to investigate the three-phase Y connected generator. This before I want to do this assignment, so I need to generate the objective first. What I need to find and or what I need to investigate or determine. So for the second objective is to make sure students know about the Malaysia standard electricity supply. Uh, Third is to study and evaluate the active power absorbed by the loads by using two wattmeter method and the conventional measurement method. For the methodology, in this task, students are randomly assigned the value of line voltage, the value of V line minus V line that assigned for me is 275 kilovolt. By using this value, we manage to calculate the value of V phase. Here, I give you the formula that we use to get the value of V phase. V phase is equal to V line minus line over pi 3. The value of transmission loss and the value of float was determined by using student metric number itself, which means my own metric number. For an example of my metric number is which is 181091372. The value of transmission load loss and load is load transmission 72 equal to 72 plus J13, load equal to 81 plus J9. We still in the methodology part. Next is figure 1 show that the circuit that constructed by using PSIM software. Next, from the value that we obtain from the circuit, we need to find the percentage of V drop by using this formula. And this voltage formula, this voltage drop formula is equal to V supply minus with V load over V supply times with 100%. We need to calculate the value of total power that delivered to the load by using conventional method and 2 watt meter. Result, and this is for the result and discussion. V phase is equal to V line to V line over I3. Set 3. V phase is equal to 275K, which is 275K. I already mentioned it. Dr. Tiang already gave me this value. So 275K over with third 3, and V phase, I get the value for V phase is 158.77 kilovolt. In the circuit, the value of ZT is equal to ZL and equal to ZS equal to 72 plus J13, which is ZT, ZL, and ZS is the same value. I line and V I line is equal V over Z load plus Z line. IAN is equal to 158.77K degree 0 over 81 plus J9 plus 72 plus J13. So for the IAN, I get the value 1016.70 degree of minus 146.20 ampere. And for the IBN is equal to 158.77 K degree of minus 120 over 81 plus J9 plus 72 plus J13. And I get the value for IBN is negative 634.95 degree of negative 807.39 ampere. Okay, I think there's something wrong here. This is not IBN for the lower part. That is for ICN. So ICN is equal to 158.77K degree 120 over 81 plus J9 plus 72 plus J13. And I get the value for ICN is negative 381.74 degree of 953.58 ampere. In Y-Y connection, the value of I line is equal to I phase. Okay, for the I phase B is equal to minus 634.95 degree minus of 803.39A, and for the I phase C is negative 381.74 degree 953.58 ampere. And you can see the V phase load A and the V phase load B is the I calculate is the calculation that I calculate. So uh, the for the V phase load A, I get the final value is negative 63.34 K minus degree of negative 53416.2 voltage. And for the final value of V phase load B is 15.60 K degree of 269 to 1.4 voltage. We move to the next page. After we obtain the phase voltage, we can find the value of voltage drop. The voltage drop is like I mentioned before, and before this slide pun, I already put the formula for voltage drop. Okay, for the voltage drop here, I get the final value is 60.11%, and below that, show that this is the calculation of V line to line of load A, load B, and load C. For the load A, I get negative 79.18 K degree of 75933.7 voltage. And for the load B, I get the 14.01 K degree of 660.85 voltage. And for the load C, I get 5.34 K degree 26 degree of 26486.9 voltage. Next, this is we want to calculate the power factor. We're going to calculate for the power measure by first watt meter. They For the first watt meter, the value already show it is 3.3002 times with 10 power of 7 watt, and for the power measured by second wattmeter is the final value is I get 1.8579 times with 10 of power 7 watt. Therefore, I can find the total power PT is equal to P1 plus P2. Okay, so the final value is 5.158 times with 10 power of 7 watt. So this is for the conventional method, the real power consumed by the load is by using this formula. P load is equal to 3. I think I cannot, I think I don't want to waste my time, but I just mentioned the final value is equal to 5.696 times with 10 of power 7 watt. And this is the graph uh, I get for the PSIM software. Figure 2 show the value that obtained by using PSIM simulation. Okay, for the discussion, from the value that I had calculated by using all the formula, figure 1 showed how the circuit was constructed in the PSIM software in order to obtain the results. By using the V line to line that had been assigned for me, I managed to obtain the value of V phase. The value of V phase is used to get the I line of the IAN, IBN, and ICN. In YY connection, the value of I line is equal to I phase actually. So we don't need to calculate the value of I phase. After that, if we want to find the voltage drop, we must to calculate the value of phase voltage first. There are slightly different amount of value that we obtain from the simulation against the calculation. But the amount does not give much impact to our result, but by using the value of phase value, the voltage drop can be determined. For wattmeter method, based on ESA underscore V3 for the PI value, which is power factor. Power factor lagging 0.9 for the voltage level 275 kilovolt and above. So the total power is determined by using the value of VL and IL. Also, the results that obtained from the simulation is slightly different from the calculation. Even there is slightly different, the value should be no problem because it still can perform well. So this is for my last part, which is the conclusion. The three-phase AC system are considered as a balanced circuit made up of a balanced three-phase source. In the part 2, we know how to calculate the active power from the voltage and current measurement in bracket Y connection lah. Next, we can use 2 wattmeter method to measure total power. Then we can calculate the active power from the voltages and currents measurement. So overall from this experiment, we understand and I understand about Y connection, delta connection, and how to use 2 wattmeter method. Yeah, we already reached for the end of page. So I think that's all from me, Dr. Tiang. Thank you for listening my presentation, even though I'm not good enough in present. I hope Dr. can uh, understand what I try to give, what I try to explain to you just now. Thank you again, Dr. Tiang. See you again. Bye.